everybody, my name is Sam and today I'm going to take you through a simple walkthrough of SkyCiv Structural 3D. We're going to be looking at the various inputs when constructing a model, as well as some of the results after we solve and analyze our structure. So if you haven't used SkyCiv Structural 3D before, this is how you get access. It's through platform.skyciv.com/structural or by visiting the dashboard tile Structural 3D. Now you can start with opening an existing project, a template assembly, or uploading a file from various CAD programs and even Revit models or other structural analysis software files as well. But for today we're going to start new and we're just going to work on building a simple model or a simple frame, and we're going to explain the different inputs that are required when building these models. So the user interface, to begin with, we have all of our inputs on this left panel. They're clearly identified and labeled with helpful tooltips so you can see exactly what you need to build. But generally we would like to work from here downwards. We also have some options in this top nav bar, some editing options for the various elements in your structure, as well as some tools such as the repair model tool, which will help identify and repair issues within your structural model. Then we have some other options here, like get help or documentation. This is very helpful when learning the program, just to find your way around the different features and functionality that we have in Structural 3D. A lot of these articles come with videos and detailed step-by-step walkthroughs. Finally, if you're on one of our professional plans, you will have access to the live chat window here, which will connect you with a local engineer that's able to help you with any questions that you might have along the onboarding process. So let's start by modeling a structure. To begin, I'm going to start adding some nodes. And nodes represent the start and end point of all your members, as well as various other information such as your supports or point loads or plates. So we need nodes to define the geometry of our structure. And nodes are typically, well, they really always are, their attributes are X, Y, Z coordinates. Now you can see this is in meters. I can change this if I want to a different unit system under my settings, where I can choose imperial if my model is in feet or inches. So I've got more control over my unit system, but for the example we're going to go through today, we're going to use the metric system. So I'll just leave that as metric. So I'm just going to start inputting some of my node locations, and you can see a node will appear here. And I'll just do a sort of simple frame. And I can just tab and enter when entering my nodes. It's very easy to do. So that's my nodes. And just to show how they come into play, we're going to then use these nodes to input some members. So we're going to go 1 to 4. So we're going to go from node A, 1 to 4. Now there's various different types of members that you can add: normal, continuous, compression only, cable, rigid links, or joists. But for now we're going to just use continuous members. And it's probably the most popular ones because it will, if you do have nodes in the middle of this member, I'll just show what it looks like. But if I did have a node here in this sort of intersecting this member, it would automatically connect to that. So we can show you exactly what that means while I just continue to build my model. Once again, I'm going to add another one, 4 to 3, have it as continuous. And if we look at some of the other options here, one of my options is my section ID. Now that is going to represent the cross-section of this member. So you can see when I added the first member, I got given a default section that wasn't defined. But for this one, say this is our column, this might be our beam. Let's put this as a different section ID. Let's introduce a new section ID 2, and I'll show you how that comes into play later. But basically you could have a different type of cross-section for these two members, so this is going to allow us to do that. Angle of rotation is pretty straightforward. It's just how the member is rotated along its own axis. And I can always just hover over this eye. This is really helpful while learning the software. This will give me more information about that particular input. And if I click it, it'll also take me to that part of the documentation, including videos and tutorials, and I can learn more about adding a member in this case. And then finally we have fixities. Now fixities represent the member's start and end connectivity. So if we want to make this, say, a trust member, where we want to release the moments at the start and end of these nodes or this member, I can simply click trust, or I can go custom and then define my own fixity code. There is a really great video in the documentation here. So if you click this, there's a great video explaining what those fixity codes are. It's just a really short 4-minute video, but it will help you understand the concept behind these fixity codes because they are very important. But basically they control your end fixities, and we're going to make this a moment release or a hinge member. We also have a lot of advanced options, so things like offset. So if you need to offset the member off its axis, you can do that. But for now, let's just keep it simple, and I'll just apply that. And you can see two things. So one is it's gone green, which represents that we added a different section. And the second thing is we've had this little bubble here, which if I hover over it, it'll show me that the fixity here is not fixed. It is released. And finally, we will do another column here. And just to show you another way of doing it, I can just click and drag between these nodes. And see, I've introduced another column. I was just holding the key 1 to add a section ID 1. So I'll just rotate that. So just by clicking and rotating. And I also just want to show another feature which is really handy, which is our pen tool. So obviously we've learnt the concepts of the nodes and the members, but if we wanted to just draw something up real quick, we can also use our pen tool, which will easily kind of snap to the various other elements or nodes and allow me to just plot both the nodes and the members in one simple step. This also shows something else that we might want to edit, and might want to control, and that's mass editing. So in this case, you can see I've introduced some beams, but I've also created some columns, and they're coming through as green, which isn't correct. So what we can do is just hold the control key, and we're going to do the touch highlight, which is going from left to right, and that's going to highlight any element with that comes into contact with the blue box. Just to show that again, if I go left to right, it'll highlight anything in contact. My other option is to go from right to left, and it will only highlight things that are explicitly within the bounds of that blue box. So you can see I've highlighted all the nodes and members 5 and 7, and that's another way I can highlight. But I've actually also highlighted member 6, so you can see that's not really what I want to do. So that's why we have both options available. So going left to right, we'll just do all the contact members there. And I've selected those two. And so now I can go back to my members, multi-edit mode. You'll see that now it's editing members 5 and 7. I'm just going to change that section ID to 1. So now we have their columns. We can do the same for these beams up here. We want to make them all truss elements. So I'll do the same thing there. Okay, so we've specified some beams, columns. Now let's add some supports. So we want to restrain the structure. So obviously I'm using that highlight functionality again. But now what I can do is actually double click here where it says node ID, and it will comma separate all the different nodes that I have selected. And I've got the same restraint code here. I can do pinned, I can do fixed. And let's do a fixed connection. Once again, we have information to do with that input. So now we have some supports. So that's restraining our structure, making sure that it is solvable and stable, which is a requirement of structural analysis. Now we can go ahead and specify what these cross sections actually are. So right now they're just lines in 3D space. So if we go section ID, click that section and go builder, this will open up our section builder, and we're able to load from a library, or we can choose from custom shapes. But this is providing the cross section for our member. So let's do a Australian beam. Let's do a steel grade. Do a hollow rectangular for the columns, and we'll do something like a 150. Submit that. And you'll see that's now updated. It's given a little shape, as well as giving me information about what those black elements are there. And then we can do the same for here, but let's try a little shortcut. Let's do the quick load, and we can go Australian, or we can even search. So maybe it's a UB 150, something like that. So it's a really quick and easy way to load in, common shapes out of a section library. Now, one thing I really like to do at this stage is just open it up in the 3D renderer. Now, the 3D renderer will provide more detail in terms of the cross-section. I can see they're quite slender elements, and so sort of some things that we might want to look at. So we can either make the sections larger, but in this case, it's probably more to do with the fact that this member is 10 meters long. So it's really helpful in identifying any potential issues in the model. So one thing we can do is just simply move these nodes a little bit closer using the mass edit functionality. Same for here, where this member is 8 meters, which is still quite long. And when I do select those nodes and click nodes, it'll show me that there is a common Z position there of -8. So we can just change it to, say, -4. Get something a little bit more reasonable. Not sure what changed there. Maybe there was a additional functionality that kind of prevents, it will continue to link the member, but let's just, you can turn that off in the settings, but I'll leave that on for now. So we'll do the same thing we did before. So now if I open up my renderer, I can see it's a little bit more filled out, but still there is probably going to be some slenderness issues, but at least I'm able to clarify any issues that might exist in my model through user input, just by seeing the model in 3D space. You can also do this with 3D members. You can actually just see it in your normal wireframe mode, which is quite helpful just to switch things on and off, or even 3D members on hover as well. So that's a little bit about the structure. Now we can just add some simple loads. We can do distributed loads, we can do moments, point loads, but I might also show this area load functionality, which is really quite useful. So this will automatically calculate the tributary area that's required of that top level. So we'll just put in the corner nodes. So let's do 5, 7, 3, 4, and it'll indicate where that pressure will be applied. And let's do a -1 kPa force, and we'll do a one-way load. Let's apply that, and also need to give it a load group. So let's call this a live load. You can see the whole pressure has been applied. And if I visit this right visibility and go to my equivalent area loads and just switch that on, I can see how it's distributed the loads to the members. And if I click that area load, it'll also provide me with a variance check just to make sure that all my pressure is being applied to these members correctly. And this is really helpful if, say, I want to introduce some more members there. I can use some of this right-click functionality, which has a lot of great features in there. So I've introduced some cross members. Now it's automatically detected that and recalculated the distributed loads as per these tributary areas. And you can see it's done that with 100% accuracy. So that's a really handy feature, area loads. But other than that, you can just apply simple distributed loads as well. So maybe we can add some wind loads here. So I'm just going to highlight the members that I want to apply my distributed load to. Double click there as a shortcut, and we'll apply them in the X direction. 1.5, 1.5. We'll make this a wind load. So I can give this any name I like, but I'm just using fairly simple names. And you can see now I've got two different types of load groups. I can even color coordinate those. So if I have multiple wind loads or live loads, they will appear the same color as well. So that's really helpful. And finally, we can do some load combinations. So let's just import some load combinations from some common design standards. We'll do the Australian code. And I've given these names, so live load, so let's change that to a live load. It might be a floor load. And the win load is win load. And I'll just import those. So now I have a range of different or common load combinations that I'm going to run when I'm running the structural analysis. So I've built my model, I've provided section properties, I have applied some loads, and I've supported it at the base, so I'm ready to solve my structure. So to solve, I'll just go under solve here, and I have a few options for the type of analysis that I want to run. And let's run a linear static and buckling analysis, because the members were quite slender, so this will give us a good opportunity to check whether there's any buckling occurring in those members. Okay, so that structural analysis ran successfully with a few warnings. And I'm able to now review some of those results. So I have my different load combinations here. So I didn't actually apply any dead loads. That's why there was actually no reactions for the dead loads. But what I can do is select one of the ones with a load, like my win load, or I can look at the load cases individually, which is really helpful. Or I can actually look at my envelope max, which will show me the absolute worst case in all of my different load combinations, which is really helpful when I'm designing. So now let's have a look at some of the results. So I've got reactions, and I'm just holding S and scrolling the mouse. That's how I'm scaling that. Or I can use this scale here. And I can see the different reaction forces. Likewise, we have shear force diagrams. I can select these to kind of isolate them or even highlight them. Same way I was highlighting in the modeling mode. Same with moments. So we can highlight these. Just get an idea what's happening in that part of the structure. Axial force, torsion. Now all these reactions, all these forces, these internal forces, are with reference to the member's local axis. And I can review that just by going here to local axis. So for instance, the bending moment around Z will tell me the bending moment around the Z axis, which is this blue of this member 6 here. And I can use the same Cartesian colors here. So my Z is my blue, so this is the bending moment about Z. So you can see if I turn on the bending moment about Y, that's probably a bad example because there's no force there. Let's have a look at another case. Here we go. We can see that is the shear force in the Z direction of the member, which is this blue member. So it's really important to know your local axis is what the forces are representing. So in the shear in Y, you'll see that is now in line with the green axis, which is my Y for that member. So that is an easy way to see where your member axis is, and that's important, especially if you're rotating your member. So just a note on the point of reference for these elements. Finally, we have displacements, and again, this is a helpful one to scale, just to see how your connectivity of your members is behaving. So we had some pinned members, and you can see that looks like that is released in the moment, because you can see it's not too rigid. So we're seeing that sort of deflection from the lateral force. You've got all these options too, so you can turn on some, you can turn on spans as well. That's really helpful. And you'll notice that some are actually highlighting red, and this is indicating that it's exceeding some of these sort of limits that we put in place. So L over 250 is the limit in this case, and you can see that some members are exceeding that with L over 160. And yeah, that's a nice easy way to detect if there's any issues in the model that you want to review. The software can help you identify what some of those are. Likewise with the stress, some of the stress values will indicate a red color if there is anything beyond the yield stress of the material. Fortunately here we don't have that problem, but it will just help you identify concerns in the design. And finally, we also have a summary, which is really, really helpful for that same reason. It'll give you some common values. It'll give you buckling. We ran a buckling analysis. Looks like we're not buckling, so that's good. That's something we can check off, as well as, but there are some sort of deflection, kind of serviceability concerns that we might have with the model. But we can also check the material yield and strength just for a quick snapshot through all of our load combinations, just to make sure we're looking at some of the first principles and considering that as part of our design. So there you have it. That's a very simple walkthrough for how to model and analyze a structure within a few minutes. We hope that you found this useful, particularly if you are a new user of SkyCiv. But if you do have any questions along the way, there is some great documentation with videos. And if that's unable to answer your question, you also have the live support too, to connect with one of our engineers who will be happy to help you with any questions that you have. So thanks a lot, and we look forward to seeing you on the platform.